When you come across an integrand that scares you or you don't know what to do, I want you to at least try something. So don't just stare at it and say, I have no idea what the antiderivative is, I'm going to move on with my life. Give it 3 seconds and think, well, what could I try? If there's more than one instance of the variable, probably you're going to need use substitution, unless it's a simple multiplication or division, like there's some algebraic way to simplify the integrand. Otherwise, you'll need to make a substitution to simplify it, if it's not clear to you what the antiderivative is. So, in this case, it looks like we could use something to be u. If you take t, which is in the denominator, then the derivative of u is the derivative of t, which we have, but that doesn't really do us anything good with the natural log of the square root of t. He's still there. There's no way to solve this for the natural log of the square root of t. So it doesn't get us anywhere. Oh, it does. It does get us somewhere, right? If u equals t, then we could have u there, and we could have u there, but then we have exactly the same problem. So we've changed the variable completely to u, but the integrand will look exactly the same. You just put a u where there was a t. So we need to take off a little bit bigger bite for u to make this get simplified. So let's revisit this idea. What if we let u be the whole natural log of the square root of t? Then the derivative of u is 1 over the square root of t times the derivative of the square root of t, which is 1/2 t to the minus 1/2. So that's 1/2 times 1 over the square root of t times 1 over the square root of t, which is 1 over 2t dt. And we actually kind of have that. So let's open up our integrand here. Let's call it the natural log of the square root of t times 1 over t times dt. Well, if du equals 1 over 2 times t dt, then 2 du equals 1 over t dt if I multiply both sides of that by 2. So this guy is twice du, and this thing was u. That lets us simplify the integrand to be simply 2u du. Well, we can find the antiderivative of that, no problem. 2's along for the ride. U goes up 1 power from 1 to 2, and we divide it by 2. And the 2's cancel. Replace the u with an x, or the t expression in this case, so that's the natural log of the square root of t squared plus c, plus the constant of integration. Be careful that you notice that the square root and the square do not cancel in this case. That is because it's the whole natural log of the square root of t that is squared in this situation. Natural log times natural log. So the operator of the natural log needs to be squared. This is completely different than the natural log of the square root of t and then just squaring the square root of t. That, in fact, is the natural log of t. Another thing to note is the value of knowing or remembering your natural logarithm properties. So I know that there are at least a couple of you out there that know that the natural log of the square root of t times 1 over t dt, we could rewrite the 1/2 that came from the power as the indefinite integral of 1/2 the natural log of t times 1 over t dt. Then it's very clear and not tricky at all to say that u should be the natural log of t and du should be 1 over t dt. A whole lot less overwhelming because there's the function, natural log of t, and its derivative right next to it. So that just screams, hey, use u substitution to solve this. The 1/2 is along, right? So it's just 1/2 times the indefinite integral of u du. And the antiderivative of u, like we said, the half is around, u gets bumped up 1 power to 2, divide by that 2, equals 1/4 u squared. Oh, that doesn't match, right? 1/4 u is the natural log of t. Plus c, that's not the same as the natural log of t squared. Why not? Like, why don't these things, these two antiderivatives we have, look exactly the same? What if we work on this one for a second? The natural log, let's work on this guy for a second over here. The natural log of the square root of t all squared. Well, this square root that's like the natural log of t to the 1/2 all squared. And the 1/2 is a power, so we can come out the half natural log of t all squared. And that's this, we can share these exponents. 1/2 squared times the natural log of t squared. So I forgot this guy and square it. And then they do in fact match, because 1/2 squared is 1/4. 1/4. And the natural log of t all squared. So believe it or not, those two things that look very different were exactly the same antiderivative. So really it's just your approach. What road do you want to take? What kind of rules do you remember? Use them to get to the antiderivative.